Close your eyes and imagine standing on a golden shore, not sand, but lava. The ground beneath your feet is 465 degrees Celsius, hot enough to melt zinc through your boots instantly. You cannot see the sky, because above you hangs a cloud layer 70 kilometers thick, not water vapor, but concentrated sulfuric acid. Every trace of heat is sealed inside. The entire world has become a pressure cooker that has been burning for billions of years and never gone out. Where you are standing is called Venus. Just 41 million kilometers away from us, in cosmic terms, that is practically next door. Yet its surface temperature is 465 degrees Celsius, its atmospheric pressure is 92 times that of Earth, and the entire planet is smothered beneath dense layers of sulfuric acid cloud. Sunlight gets in. Heat cannot get out. This is the most real hell in the solar system, and it exists within arm's reach. Now I need to tell you something many scientists refuse to discuss in public. Venus once had oceans. Not metaphor, not speculation. Models from NASA and data from the European Space Agency converge on the same conclusion. Approximately 2 billion years ago, Venus may have had liquid water on its surface, a temperate climate, and all the foundational conditions life needs to emerge. It was not merely Earth's neighbor. It was once Earth's identical twin. Then something happened. Something that evaporated every ocean, transformed its atmosphere into a poison chamber, and drove its surface temperature past even Mercury, the planet far closer to the Sun. Venus burned itself alive. The mechanism was called runaway greenhouse effect. And today, Earth's atmospheric CO2 concentration is climbing at a rate unprecedented in all of recorded human history. I am not telling you a distant cosmic story. I am holding up a mirror. Let us start with a quiz. Among the 8 planets of the solar system, which has the highest surface temperature? Almost everyone's first instinct is Mercury. After all, it orbits closest to the Sun at just 58 million kilometers, 1/3 of Earth's distance. That answer is wrong. The planet with the highest surface temperature is Venus, averaging 465 degrees Celsius. Mercury's sun-facing side peaks at 430 degrees, but its night side plunges to -180. It has no atmosphere to hold the heat. Venus has an atmosphere 92 times heavier than Earth's, composed almost entirely of carbon dioxide, wrapped in a shell of sulfuric acid cloud. This armor locks every last trace of heat inside. Energy enters freely and cannot escape. That is the ultimate expression of the greenhouse effect. Venus's diameter is 95% of Earth's. Its mass is 81.5% of Earth's. If you placed both planets side by side in space with no labels, you could barely tell them apart by silhouette alone. Earth scientists have a term for the relationship between Venus and Earth: planetary twins. But these twins walked toward 2 completely different fates. One became the cradle of life, oceans, forests, cities, civilization. The other became the most terrifying hell in the solar system. What happened between those 2 outcomes? The answer to that question does not belong only to Venus. It belongs to every single one of us. To truly understand Venus's death, we must first grasp one physical mechanism. The Sun radiates shortwave energy, visible light, and ultraviolet radiation. This shortwave energy passes through the atmosphere effortlessly, strikes the surface, gets absorbed, and the surface then releases that energy back out as longwave radiation, what we call infrared. Ordinary nitrogen and oxygen are transparent to infrared. The heat escapes the atmosphere freely, dispersing into the void of space. But the carbon dioxide molecule has an extraordinary structure: 3 atoms arranged in a linear chain. When infrared radiation collides with this molecule, it triggers internal vibrational resonance. That resonance is the physical essence of CO2 absorbing heat. The absorbed energy then re-radiates in all directions, and half of it points back toward the surface, effectively wrapping the entire atmosphere in a double-sided thermal foil blanket. This is the physical truth of the greenhouse effect. At the right concentration, The greenhouse effect is life's greatest benefactor. It is what keeps Earth's average temperature at 15 degrees Celsius rather than the theoretical -18. Without it, Earth's surface would be a permanently frozen snowball, oceans solid, life impossible. But Venus's problem was that this system spiraled completely out of control. Astrophysicists call this process the runaway greenhouse effect, the point where no equilibrium can ever be found again. Understanding Venus's death requires imagining a vicious death spiral. First loop, Venus sits slightly closer to the Sun, receiving roughly 10% more solar radiation than Earth, causing a slight temperature rise. Second loop, elevated temperatures accelerate ocean evaporation. Water vapor is itself a greenhouse gas, even more potent than CO2. More water vapor enters the atmosphere, trapping more heat. Temperature rises further. More ocean water evaporates. The spiral begins turning. Third loop, oceans begin shrinking, temperatures climb again. Fourth loop, oceans evaporate entirely. Carbonate rocks, which had stored enormous quantities of CO2 for hundreds of millions of years, begin decomposing under the heat, releasing all of that stored carbon back into the atmosphere. CO2 concentration explodes. Fifth loop, sixth loop, seventh loop, the spiral has no end. The system can no longer find a new equilibrium. Venus's current atmospheric CO2 concentration, 96.5%. Earth's current atmospheric CO2 sits at 425 parts per million. Before the Industrial Revolution, it was 280. The numerical gap looks enormous. But here is what we tend to forget: Venus's death was not completed overnight. It took hundreds of millions of years. And the tipping point where it first lost control may have been only the tiniest increment above the state Earth is in today. The universe does not pause because you refuse to believe. Physical law does not take a break because you are busy. Here we enter territory the entire field of planetary science is still fiercely debating. Did Venus ever actually have oceans? One camp of scientists says yes. Their core evidence comes from isotope analysis. The ratio of deuterium to ordinary hydrogen in Venus's atmosphere is far higher than on Earth. This imbalance is the chemical fingerprint left behind as vast quantities of water escaped and evaporated over billions of years, like the salt crust left on the bottom of a pot after the water has boiled dry. The opposing camp, the dry Venus school, fires back. Venus's geological record shows its surface underwent a catastrophic volcanic resurfacing event approximately 700 million years ago. The entire planetary crust was essentially overwritten. All early geological evidence was erased. We have no way to confirm whether those oceans actually existed, or whether they are simply artifacts of our models. The two sides remain deadlocked, but the debate itself is already enough to send a chill down your spine. This debate took a dramatic turn in 2021. Scientists detected a signal for phosphine, chemical formula pH3, in Venus's atmosphere. On Earth, phosphine is produced almost exclusively by biological activity or highly sophisticated industrial synthesis. Though the signal was subsequently challenged and repeatedly reanalyzed, it opened a possibility that left everyone silent. Somewhere in Venus's upper atmosphere, some form of microbial life may still exist today. This is not science fiction. This is an active debate in the journal Nature Astronomy. At certain altitudes within Venus's cloud layers, temperatures range from roughly 0 to 70 degrees Celsius, theoretically within the range where life can survive. Some extremophile microorganisms may have fled upward into the high atmosphere during the catastrophic transformation of Venus, persisting there in ways we do not yet understand. But the most terrifying part of this debate is not whether life exists on Venus. It is the logical implication. If Venus was once habitable, then the path from habitable to hellish has a documented precedent. Current Earth climate models show, if global average temperatures rise 4 to 5 degrees Celsius above pre-industrial levels, wet bulb temperatures in certain regions will exceed the human body's ability to shed heat, and people will be unable to survive outdoors. If warming exceeds 8 degrees, the ocean's layered structure collapses, and methane hydrates on the deep seafloor begin releasing on a massive scale, triggering a new feedback loop dozens of times larger than anything happening today. Nobody knows where that road ends. Venus does. Let me take you through a thought experiment. Not a few hundred years from now, but what happens if nothing changes, if we allow that runaway machine to run unchecked? Year 0, today. You are standing on a street in Shanghai. Summer. A heat wave rolls in. You frown, pull out your phone, and see a notification. This year is the hottest on record. You swipe it away and open a food delivery app. In that single dismissive swipe, the clock begins ticking. The spiral begins turning. No warning. No countdown. No dramatic opening. Year 100, global average temperature is 3 degrees Celsius above today. Permafrost across Siberia and Alaska thaws on a massive scale. Locked within that permafrost are hundreds of billions of tons of organic carbon, now releasing as methane and CO2. This is a carbon emission source that no human technology can switch off. Greenhouse gas concentrations are no longer driven by human activity alone. The Earth itself has begun venting into the atmosphere. Sea levels rise 1.5 meters. 200 million climate refugees begin to move. Year 1000, global temperatures are 5 to 6 degrees above today. This number is not unfamiliar in Earth's history. During the end Permian mass extinction approximately 252 million years ago, a temperature spike of similar magnitude wiped out 96% of marine species and 70% of terrestrial species. Most of the tropical world's population can no longer work outdoors. Agricultural zones shrink toward the poles. Food systems collapse. Civilization begins unraveling at a pace never before witnessed. 1 million years from now, this is a moment I need to slow down to describe. High temperatures cause ocean evaporation to exceed rainfall replenishment, and sea levels begin a net decline. Simultaneously, warmer oceans lose their ability to absorb CO2. Today's oceans handle roughly 25% of all human CO2 emissions, making them the planet's most critical carbon sink. That sink is disappearing. Worse still, as ocean temperatures rise, dissolved CO2 begins escaping back into the air. The ocean flips from carbon sink to carbon source. The moment that transition occurs, the runaway becomes irreversible. Imagine looking down at Earth's surface, no oceans. The floor of what was once the Atlantic lies exposed, rust-red rock blanketed in salt hundreds of meters thick, left behind by evaporation. Where the Pacific once stretched for thousands of kilometers, there is now nothing but a basalt wasteland. The atmosphere is now primarily water vapor and CO2, atmospheric pressure dozens of times today's level, surface temperatures exceeding 400 degrees Celsius. Sunlight refracts and scatters through the dense atmosphere, casting a diseased orange-red glow across the horizon. There is no wind, or rather, there is wind, but it is a sulfuric acid vapor storm moving at hundreds of kilometers per hour, shredding every solid structure it encounters. No life of any kind. The last organic molecule on this planet dissolved quietly into nothing, at some nameless moment hundreds of millions of years ago. This is what Venus looks like today. Not prophecy, a letter already delivered, still unopened. Let us pull the view back even further. The Milky Way contains approximately 200 billion stars, a significant portion of which host rocky planets. Astronomers estimate that the number of Earth-like planets within habitable zones throughout our galaxy may number in the tens of billions. And yet we have never received a single signal from any alien civilization. This silence is known as the Fermi paradox. The universe is so ancient, so vast, the probability of life arising should not be low. Why is there no other voice out there?